Today let's talk about Leetcode 3327 problem. First part is description. You are given an tree. And there is some number. There is one number from 0 to n minus 1 in the every node of the tree. There are totally n nodes in this tree. In addition, there is also a character A, B, C, D, Z. There are different or same character on every node. So what we need to do is first of all, we need to get a string for every tree or subtree in the first order string. That means for every subtree we need to get the character from the left. First is get the character from the left node, left children. Second is the right children, and finally is the parents node. For example, if the tree is this character is A, B, C, D, E, so the post order string will be first is left, so this is first, right, second, first, this is second, this is third, this will be fourth, finally will be 5. So the order will be C, D, B, E, A. So this is the post order string. What we need to do is to check every substring. Every post order string for every subtree is a palindrome. That means it is a palindrome string. For the definition of palindrome, that means it is the same from front to back or from back to front. That means A, B, B, A. If you read it from back to front, that will be A, B, B, A. This is the same with from the regular order, but there is another string that means A, B, B, A, A. If you read it from back to front, that will be A, A, B. It is different, so it is not a palindrome, but this is a palindrome. This is the definition of palindrome string. So what we need to do is to return a boolean integer that can show the post order string for every subtree is a palindrome. This is the definition of this problem. Next part, let's talk about the solution. For this part, first of all, we need to mathematical algorithm to solve this problem. Let's talk about the definition of the mathematical algorithm. What is the definition about the mathematical algorithm? For this algorithm, you are given a string S, and you will return an integer array P. Pi means the largest distance or longest distance. Longest distance based on the center of I to make the whole substring as a palindrome. That means, for example, the X, Y, A, B, A, T, P, Q. For this substring, if the I is this, if this is the ith index of the string, the Pi will be 2. Actually, py will be 1. That means the longest distance make the whole substring as a palindrome. That means this substring is a palindrome. So pi will be 1. For if this is I, pi will be 0 because the longest possible palindrome substring at the center of P is 0. So pi is 0. This algorithm can be realized in the time complexity of ON. That means it's very quick. So for this problem, we need to match the algorithm to solve this problem. First of all, we need to understand how match the algorithm works. So this is the definition of this algorithm. This is the first part of the solution. Next part, we need to talk about the definition of the problem, more details about this problem. First of all, we can get for this substring. Actually, for every substring, if we get the post order string of the whole tree, if we get the whole tree, that means, for example, we can get it the whole tree, the post order string, that we can make it as the root s. So we will know the post order string of subtree will be the substring of root s. For example, for this subtree, the first elements will be A, B, C, D, E, F, G, H, I, L. For this substring, the root S will be A, B, C, D, E, F, G, H, I, J, K, H, I. That means this is J, this is K. This is the root S. For the substring, for the post order string of this is the whole tree. So for the post order string of the subtree at the root of S, that means this part. That means root C is A, B, C. So this is this polytree. For another, that means this subtree, the post order string of the subtree at the root of I. Root I will be G, H, I. Okay. G, H, I. This is the substring. So, till now we will know the post order string of the subtree is the substring of the whole post order string of the whole tree. That means if we get this, it contains all information about this post order string of the subtree. So what we only need is this string. After traverse every elements of the tree, we can get root S is the first element. Secondly, we can get for every elements in the root S, we can get the index or the position. That means the position integer array means the position. Position, the key means the index in the root S, and the value will be the root node of the substring. That means, for example, JHI, it can be I. That means this node. you can see the index in the node I. Index of I. This can help us to transfer the answer to the required position. Okay, secondly, we can get a position array. Thirdly, we can get the length of the subtree. For example, length I will be 3 because there are 3 nodes in this subtree and 3 elements for the substring. So we can get a length integer array, position integer array, and a root string. Right now, what we have is first of all is a substring, is a whole string, and we know every substring in this whole string, it is the symbol of subtree. So what we need, after that, we need to check every substring in the whole string if the substring will be a palindrome. So we can bridge the what we need with the manager algorithm as mentioned below. More specifically, for example, let's take an example, root S as these elements, B, C, C, B, A, D, E, D. For example, if every time we need to check every substring is a palindrome, for example, we need to check this palindrome. So, or we need to check this palindrome, the first palindrome. The substring is A. Actually, the position. We don't need much about the position. So, the length 1, 2, 3, 4, 5, 6. Length 6 will be length 6 can be 6 because this present a substring. So if we want to check if the substring is a palindrome, we can first of all we can get the center index of the substring. So we need to check the p center. If it is larger than the length 6 divided by 2, because this is the half of the whole length. If the p center means the longest possible value, make the whole substring as a palindrome based on the center as a center. So if the p center is larger than length, then half of the length. If the p is larger than length divided by 2, that means this can be this substring or this subtree can be a palindrome. Example, if this is not, that means it is not a palindrome. So we need to return no for this subtree as a substring in the whole string. So secondly, if we need to check the next part, another part, actually maybe there is a substring from BA to D. So secondly, we let's take the last 3 numbers as an example. So length of 9 will be 3. First of all, we need to find the center. That means the center. That means the center is E. So what we need to check is also the center. Vs length divide 2. Length 9 is 3. So what we need to check is p length vs length 3 divided by 2. This is the same situation compared that above. So this is all about so for every position we can print answer. If it is yes, let's continue for this. If this is yes, we can check answer p position I true. In contrast, this will be false. This is the solution of this problem. That means we can check the p center. That means the largest possible distance make the whole string at the palindrome is larger than half of the length. Half of the length of the substring we need to check. If it is larger, we can return yes. In contrast, we need to return no. So this is all about this. This is all solution about this problem. Next part, let's talk about complexity. First is time complexity. Actually, for the post-order traveler, what we need is ON. For the manager algorithm, the time complexity is also ON. So the finally time complexity will be ON. For the space complexity, we don't need extra space to store variable. So the space complexity is also ON. Actually, we need several string or integer array such as the position, length, but I mean ON plus N plus N is also ON. It's also ON. So the space complexity is also ON. This is all about this problem. Thanks for watching.